In the coming months, we look forward to commencing the production of commercial samples for our partners, says Lis Energy CEO Li Finniear. This is thrilling news. The company has announced that the production of commercial samples for the groundbreaking 20-layer battery cell based on semi-solid lithium-sulfur technology is about to commence at the end of the year. This remarkable development comes hot on the heels of the tremendous success of their Gen 3 lithium-sulfur battery cell, which has achieved a staggering 45% improvement in volumetric energy density, reaching an astounding 540 watt-hours and a higher gravimetric energy density of over 400 watt-hours per kilogram. So, how does the Gen 3 lithium-sulfur battery cell achieve such high performance? Why can it become an absolute game-changer for industries? Join us as we cover the latest news about this remarkable battery in today's episode of Tesla Car World. Welcome back to our channel, and before we begin, we ask that you show your support by subscribing if you haven't already, and ringing that bell so you don't miss out on any of our interesting videos in the future. Now, let's get started on today's content. LIS manufactures 20-layer battery cells utilizing third-generation or Gen 3 semi-solid-state technology by embedding unique nanomaterials, boron nitride nanotubes, or BNNTs, and a new nanocomposite that's invented called Li-Nanomesh into the cells to enhance their strength, life cycle, and performance. So, how much does the 20-layer battery cell cost? As the electric vehicle market continues to grow, there's a rising demand for batteries that aren't just efficient, but also affordable. The shift towards lithium-sulfur technology could bring about a significant impact on battery prices, with experts estimating the cost to drop as low as $17 per kilogram. This suggests that the final price is estimated to be as low as $60 a kilowatt-hour versus $90 per kilowatt-hour. Meanwhile, right now, the average price of a lithium-ion battery is about $120 per kilowatt-hour. This substantial price reduction would make electric vehicles more accessible to consumers, potentially leading to widespread adoption in the market. According to Selena Mikoljiak, the Chief Battery Technology Officer of the startup Lighten, a commercial lithium-sulfur battery could revolutionize electrification, making it abundant and easy to electrify everything. This exciting prospect could transform the way we power our devices and vehicles, providing a cost-effective and energy-efficient solution for widespread electrification. Right now, lithium-ion batteries face challenges due to the constrained supply of nickel. Additionally, cobalt, another vital component in lithium-ion batteries, is predominantly sourced from mines in the Congo, where human rights issues plague the industry. The abundance and low cost of sulfur make it a promising alternative for lithium-sulfur batteries. These batteries could potentially reduce our dependence on problematic regions, offering a more sustainable and ethically sound energy storage solution compared to current lithium-ion battery packs. The shift towards lithium-sulfur technology presents a promising future for the electric vehicle industry, with the potential to drive down costs and make eco-friendly transportation more accessible to all. As this technology continues to evolve, we can look forward to a greener and more affordable future for electric vehicles, providing a cleaner and more sustainable way to move around while contributing to a healthier planet. How does the 20-layer battery cell forecast development for the future? In the rapidly advancing world of technology, batteries play a crucial role in powering our devices and our vehicles. Thankfully, the 20-layer battery cell represents a groundbreaking development in battery technology that addresses these concerns. This innovative battery boasts a remarkable 1,000 charge and discharge cycles compared to today's lithium-ion batteries. The Argonne scientists achieved this success by employing a cutting-edge billion-dollar X-ray diffraction machine in their lab that allows them to observe the remarkable properties of the lithium-sulfur cell. With a weight energy density of 400 watt-hours per kilogram and a volumetric energy density of 540 watt-hours, this battery is not just lighter, but also offers significant cost and safety advantages compared to the traditional options out there. One of the most significant advantages of the 20-layer battery cell is its low flammability risk, a stark contrast to the well-known fire hazards associated with lithium-ion batteries. The secret lies in the battery's electrolyte material, the solution that facilitates the charge and discharge cycle. This innovative material significantly reduces the risk of fire, providing American seniors with the peace of mind they need while using their electronic devices and electric vehicles. Safety is a top priority, and this battery technology delivers on that front. The benefits of the 20-layer battery cell extend far beyond safety. With its exceptional high density, this battery packs more power while weighing less. This means lighter devices and electric vehicles, making them easier to handle and operate. Moreover, the cost-effectiveness of this battery technology is noteworthy, alleviating financial burdens and encouraging widespread adoption among seniors. The researchers at Argonne have truly harnessed cutting-edge technology to perfect this lithium-sulfur battery. By utilizing state-of-the-art X-ray diffraction machines in their experiments, they have ensured the highest standards of quality and precision. The result is a battery that not only competes with today's lithium-ion batteries in terms of performance, but also exceeds expectations in terms of safety and cost efficiency. Embracing this advanced battery technology will undoubtedly enhance the lives of American seniors, enabling them to stay connected and mobile with confidence. The prolonged cycle life of 1,000 charge and discharge cycles ensures that most devices and cars powered by this battery will stand the test of time. Moreover, with its reduced flammability risk, customers can rest assured that their safety is well taken care of. As for the new battery, it can be considered a game changer in the world of energy storage. Its remarkable energy density, combined with enhanced safety features and cost effectiveness, make it the ideal solution for various applications. For us personally, this battery serves as a reliable and efficient power source for electronic devices, ensuring longer usage times and lightweight portability. It would also make electric vehicles more practical and accessible, providing a greener and more sustainable transportation option. Overall, this innovative battery technology promises to have a positive impact on our daily lives, improving the way we use and rely on energy in a more environmentally friendly manner. What do you consider this new battery to be? What use will this battery serve for you? How far away are the 20-layer cells from commercialization? In the coming months, we look forward to commencing the production of commercial samples for our partners, says Finniear. The Lis Energy development team's actively working to develop cell cycle testing and characterization results to produce an industry-standard data sheet on the new 20-layer cells. It's expected that the 20-layer battery cell, based on semi-solid lithium-sulfur technology, is well underway and is set to be officially commercialized by the end of the year. Unfortunately, it is quite disheartening that this new type of battery won't be used in the production of electric vehicles immediately. Instead, it's been applied in aviation applications and unmanned spacecraft. Perhaps the dream of incorporating it into trams will take a little bit longer. While researchers and developers have made significant progress in exploring new generations of batteries, the pace of development in the industry appears slower compared to academia. In academia, the progress in the research of 20-layer cells has been as fast as a bullet train, resulting in fruitful results over the past decades. Various advanced materials have been synthesized, and most of them can be produced on a large scale. Despite the contrast in the speed of development, we can remain hopeful that the industry will catch up to realize the full potential of LIS batteries for a wide range of applications, including our electric cars. As the technology continues to advance, we can look forward to a more sustainable and efficient future thanks to the continuous efforts of researchers and innovators in the field of battery technology. How's the 20-layer battery cell better than the most widely used batteries these days? In the realm of battery technology, various enhancements have been made in pursuit of higher energy densities and improved efficiency. Comparing different generations of batteries, we find interesting variations in energy density metrics. Example: the third-generation lithium-ion phosphate, or LFP, cell boasts an energy density of 290 watt-hours and 160 watt-hours per kilogram, which is about 1.37 times lower in weight energy density than the 20-layer battery cells. Surprisingly, the volumetric energy density of LFP cells remains pretty comparable to that of the 20-layer cells. On the other hand, contemporary Amperex Technology Company Limited, or CATL, has developed third-generation nickel-cobalt cells, which exhibit an energy density of 450 watt-hours. These cells outperform the 20-layer battery cells in terms of weight energy density, and interestingly, they lag behind significantly in volumetric energy density, being approximately 2.16 times lower. The NCM cells managed to achieve an energy density of 250 watt-hours per kilogram. Meanwhile, Tesla's 4680 cells, featured in the Model Y all-wheel drive and Cybertruck model, show an estimated energy density of around 272 watt-hours per kilogram. While this is an impressive achievement, it's worth noting that it falls short by 1.98 times when compared to the volumetric energy density of the 20-layer battery cells. The race for a higher energy density in batteries has led to distinct advancements across various generations of cell technologies. Each generation offers its own trade-offs between weight energy density and volumetric energy density. As technology continues to evolve, these insights will drive us closer to the ideal balance of higher energy densities, affordability, and sustainability in the realm of battery innovation. And the most important part of today's episode is, how does the 20-layer battery cell have the potential to revolutionize electric vehicle production? Lis Technology holds immense promise for revolutionizing electric vehicle batteries. The 20-layer battery cell, developed by Lis Energy, offers several key advantages that makes it a game-changer for the EV industry. First, it significantly extends the driving range of EVs. With a remarkable 45% improvement in volumetric energy density and a gravimetric energy density exceeding 400 watt-hours per kilogram, the 20-layer battery cell enables electric vehicles to travel much farther on a single charge. This improvement in energy density is a huge breakthrough, providing drivers with increased confidence in the practicality and convenience of electric vehicles. Safety is another critical aspect addressed by Lis Technology. The use of having low flammability electrolyte in the 20-layer battery cell enhances the safety of EVs, effectively reducing the risk of fire incidents. This safety feature reassures both consumers and regulatory authorities, further encouraging the widespread adoption of electric vehicles. Moreover, the 20-layer battery cell contributes to lighter and more compact EV designs. Doubling the gravimetric energy density while maintaining a comparable volumetric energy density enables a more compact battery pack. This not only frees up valuable space within the vehicle, offering greater design flexibility, but it also reduces the overall weight of the battery pack. As a result, EVs become more efficient and agile, enhancing driving performance, while potentially leading to cost savings by using fewer materials without compromising on performance. The advantages offered by Lis Technology are a testament to its potential to transform the EV industry. The extended driving range, improved safety, and lighter, more compact designs promise a brighter and cleaner future for electric vehicles. Customers, with their keen interest in technological advancements and sustainable solutions, can look forward to witnessing the positive impact of Lis Technology on the EV landscape. As we move towards a greener and more environmentally conscious era, Lis Technology paves the way for a cleaner and more sustainable transportation future for generations to come. Where's the 20-layer battery cell manufactured? Lis Energy's collaborated with Deakin University in Victoria and the PPK Group, among others, to create innovative battery cells that eliminate the use of heavy metals like nickel and cobalt that's found in traditional lithium-ion batteries. These new cells are manufactured at Lis Energy's facility in Geelong, Victoria, which potentially houses the largest dry room in all of Australia. The Phase 3 production line is capable of producing 2 megawatt-hours of batteries. Additionally, the Argonne National Laboratory, with scientist Guileng Zhou among the authors of a recent paper, plans to partner with the private sector to commercialize this new battery technology and develop a prototype battery. It's not just the US that's investing in lithium-sulfur research. The EU, funded by the LISA project focusing on lithium-sulfur battery cell design. There's the Korean company LG, through its energy arm of LG Energy Solutions, and they aim to commercialize a lithium-sulfur battery by 2025. There's also a German startup company called Theon that they're making their own strides to bring a lithium-sulfur battery to market soon. An even more interesting thing is that the recently passed Infrastructure and Reinvestment Act in the U.S. has allocated funds that could significantly boost battery development efforts. The IRA subsidies provide much-needed support to battery manufacturers, making the capital-intensive process more manageable and giving everyone a better chance of success, according to experts. Automakers are also actively investing in battery technology and supply chains. Companies like GM and Ford are partnering with promising battery startups and mineral suppliers. Established companies like Tesla and BYD have long been heavily invested in their own battery technology. While lithium-sulfur batteries show great promise, they still have a long way to go before becoming mainstream. The current lithium-ion batteries that power today's EV revolution have benefited from 3 decades of progress. It could take many years, if not decades, before more lithium-ion sulfur battery packs are widely used in vehicles like those from Tesla or General Motors. The first lithium-sulfur batteries are likely to be used in vehicles and devices that require extremely lightweight capabilities. Due to their higher energy density, lithium-sulfur batteries can power vehicles with significantly less weight, making them ideal for applications like drones and other small flying vehicles. The development of lithium-sulfur battery technology is progressing along steadily, thanks to collaborations between research institutions and private companies. The new IRA funding and investments from automakers are expected to accelerate battery development even further. While mainstream use in cars may still be some years away, the advantages of lightweight lithium-sulfur batteries make them promising candidates for specialized applications like drones and other lightweight vehicles. As the technology continues to evolve, we can look forward to witnessing these exciting advancements in the world of electric mobility and energy storage. What is the future of the 20-layer battery cell? As researchers continue to explore the possibilities of LIS technology, several manufacturers have already made significant strides in delivering LIS batteries for specific applications. These batteries find extensive use in industries where weight and long-lasting performance on a single charge are crucial, like drones and satellites. For instance, LG Energy installed an LIS battery in a solar-powered unmanned aerial vehicle developed by the Korea Aerospace Research Institute, successfully completing a 13-hour test flight in the stratosphere under extreme conditions of -70 degrees Celsius and just 4% of ground level pressure. In the EV space, a German battery startup named Theon is actively working to bring LIS batteries to the market. Theon's efforts are focusing on offering LIS technology to automotive customers as early as next year, signaling a potential breakthrough for electric vehicles. The advantages of LIS batteries, including higher power density, could potentially alleviate range anxiety, a concern that some surveys indicate hampers the widespread adoption of electric vehicles. The advancement in LIS technologies offer hope for a cleaner and more energy-efficient world around us. As we embrace the potential of sulfur to revolutionize our energy landscape, LIS technology may very well lead the way in transforming the future of transportation and space exploration alike. So that's it for today's episode. What do you think about changing your electric car's lithium-sulfur battery? Are producers prepared to produce them in large quantities? Since the announcement of the solid-state battery project, Toyota's stock has gone up 13%, proving that solid-state batteries are highly anticipated by both the company and its customers. Toyota Motor Company is aiming to launch 2 new types of solid-cell battery technologies that are expected to be commercialized in 2027 and after 2028. This is considered a battery with great potential for widespread use in the future, especially when it comes to electric vehicles. How much is a solid-state battery? Solid-state batteries are considered a breakthrough in terms of size and weight. Although at present, the price of this battery is expected to be a bit high, around $430 per kilowatt hour. It is higher than the cattle sodium battery because this battery only costs $77 a kilowatt hour and the 4680 is significantly cheaper at $100 a kilowatt hour. However, Toyota is likely to expand its production scale and have the methods to reduce production costs in the future, which is key to making solid-state batteries much cheaper than the initial research showed us. Toyota's leading battery specialist recently confirmed that simplifying the manufacturing process will be key to reducing the cost of this innovative technology. The company will reduce the size and weight of the battery and choose components in solid-state batteries that are efficient but not too costly. Besides, the company also doesn't put rare materials into the battery to reduce costs. Example, the company won't use cobalt in the battery composition because it's too expensive. The reason why the cost of solid-state batteries are higher than usual is that researchers and manufacturers must find suitable solid-state electrolyte materials that can conduct electricity well at room temperature. In addition, the factors of battery life and durability also greatly affect its price. Despite these limitations, Toyota has made significant progress and has had breakthrough solutions to price-related barriers. This will make solid-state batteries cheaper. How do solid-state batteries work? The operation of a solid-state battery is quite similar to that of a lithium-ion battery, Metal is used as the material for the electrodes in the current. However, solid-state batteries use lithium metal as the anode instead of graphite. It also uses a solid electrolyte instead of a liquid as in lithium-ion batteries, where the battery's electrolytes contain charged ionic particles. When the ions move from the cathode to the anode, it's said that it's charged. Similarly, the movement of ions in the reverse direction, i.e. from the anode to the cathode, discharges the battery and supplies to the current load. Besides, there's a separator that separates the cathode from the anode, preventing the liquid on the cathode side from mixing suddenly with the liquid on the anode side. But in the case of a solid electrolyte, the separator is unnecessary. Although it's more efficient because of solid electrolyte components, it doesn't complicate the battery structure more, it simply changes the composition. We can see that changing the electrolyte composition has brought many outstanding features to look forward to. What do you think about the solid-state batteries and how they work? Let us know by leaving a comment. So, why are Toyota's solid-state batteries so effective?
Well, it has benefits over all these conventional EVs. And now, charging under 10 minutes with a range of 1,200 kilometers means that it's pretty much...
It's no coincidence that solid-state batteries will be superior when they're released in the future. When it comes to a battery, the range of performance it provides to the device is of a particular interest to the customer. The first solid-state battery provides more than 20% more vehicle range up to 745 miles, 2.4 times more than a conventional lithium-ion battery. On top of that, Toyota is also proposing a solid-state battery version to be released later than 2028. This battery is even better than the first solid-state battery when it provides up to 50% of the range of up to 932 miles. According to the company's scientist, Gil Pratt, the first Toyota cars to be installed with solid-state batteries will likely be hybrids instead of pure electric vehicles. The reason said by the manufacturer is that this battery technology is more durable and suitable for the way of continuous charging and discharging operation on hybrid models. Compared to solid-state batteries with sodium cattle and 4860 LFP batteries, the solid-state battery is 3 times better because the sodium cattle battery only provides a maximum range of up to 310 miles. It also beats the 4680 battery and gives a range of about 279 miles. Charging time is also an important factor in an efficient battery. The solid-state battery's recharging speed is 4 to 6 times that of a regular battery. It charges extremely fast, from 10 to 80% capacity in just 10 minutes or less. Meanwhile, Cattle's sodium battery takes 15 minutes and the 4680 battery takes 32 minutes to reach that battery level. It can be said that the charge and discharge life of solid-state batteries is up to 10 years, while those of batteries like sodium and lithium are just 7 to 8 years. Regarding energy density, solid-state batteries can be said to be almost twice that of conventional sodium or lithium batteries. In solid-state batteries, the overall energy density can reach 300 to 400 watt-hours per kilogram, while the energy density of Cattle's sodium batteries is only 160 watt-hours per kilogram as the company first announced. Although the 4680 battery is outstanding, its energy density doesn't surpass that of a solid-state battery when it only reaches 272 to 296 watt-hours a kilogram. An all-solid-state battery uses a solid-state electrolyte. This special electrolyte produces poor flammability, so solid-state batteries are almost non-flammable. From the perspective of the chemical properties of the material, it is less affected by the ambient temperatures and has no heat loss phenomenon, and its performance is more stable and secure. Solid-state batteries can require up to 35% more lithium than current lithium-ion technology, but they do use much less cobalt and graphite. This factor reduces the cost a little, but also reduces the battery's performance. How is Toyota's solid-state battery production process? The company's been working on this technology since 2012, and it's becoming a reality as Toyota now has more than 1,000 patents on solid-state batteries, and that's more than any other automaker. Toyota's developing solid-state batteries through Prime Planet Energy and Solutions Incorporated, a joint venture with Panasonic that started operations in April 2020. Solid-state batteries have been researched for many years and have to go through many of the company's strict censorship processes. The company aims for a battery with high specifications and an outstanding range. However, production was slow until the end of the decade because the company was trying to fix a problem related to the cost of the battery. Therefore, during this time, the company's battery production process is said to be slow because inventors had to research to overcome incomplete aspects, especially in terms of cost. Toyota has said that it'll invest 730 billion yen to produce batteries for electric vehicles in Japan and the US, and production starts next year. According to the distribution, about 400 billion yen will be invested in 4 electric vehicle battery factories in Japan, and the remaining 330 billion yen will go into 1 electric vehicle battery factory in the US. It can be said that the company's investing a lot to develop new generations of batteries, in which capacity and price are the company's top priority. Currently, the electric vehicle market is almost widely equipped with lithium-ion batteries and lithium-ion phosphate batteries. This is the most efficient battery type at the moment because it also contains certain outstanding features. But it's not perfect when there are some risks such as easy loss, energy leakage, and explosion. Then, solid-state batteries will be a potential alternative in the future. So when can solid-state batteries replace those lithium batteries in the future? Elon Musk also tweeted, "Solid-state batteries are the future." Although the lithium battery has its advantages and impressive parameters, when the solid-state battery comes out, it could replace this traditional battery. The introduction of solid-state batteries was intended to overcome the imperfect aspects of lithium. The first is about the anode structure of solid-state batteries using lithium instead of graphite. Lithium can hold more electrons than coal, so the solid-state battery capacity can therefore be higher. Solid-state batteries are capable of providing higher energy densities than current lithium-ion battery technology. This means solid-state batteries are smaller, lighter, and can deliver more electrical power. This is considered an outstanding strength of solid-state batteries because battery weight's one of the top concerns of manufacturers, especially when applied to moving vehicles. It'll help electric vehicles, airplanes, and boats save storage space while ensuring enough energy to serve essential needs. The charging speed of the Toyota solid-state battery is outstanding because it has high heat resistance, which is also an advantage for fast charging. The faster the batteries charge, the hotter they get. Therefore, it's believed that it's possible to change solid-state batteries that withstand high temperatures and speed up the process. Another aspect is safety. Electrolytes in solid-state batteries aren't made of combustible materials, so they can be used at higher temperatures. Furthermore, in the case of liquids, the movement of ions slows down the temperatures, causing battery performance to decrease and voltage to drop. In the case of solids, internal resistance doesn't increase much, and battery performance doesn't decrease much because solids don't freeze like liquids, even at low temperatures. In terms of lifespan, because the battery's electrolyte's solid, it doesn't tend to be depleted after a certain number of charge cycles, which helps the battery maintain its stability for a long time and extend its life. Although lithium batteries are quite efficient, the liquid in the electrolyte isn't sustainable. Therefore, the life of the battery is largely determined by the structure of the battery. Batteries made from most sustainably sourced materials can cut carbon emissions by an additional 39%. This factor also makes the battery more environmentally friendly. Finally, the solid-state battery has one advantage over lithium batteries, which is the variety of battery designs. In lithium batteries, because the electrolyte exists in liquid form, there are structural limitations to prevent liquid leakage. In contrast, solid-state batteries have no such restriction, so they can be used in a variety of shapes, as it's easy to make them smaller and thinner, or they can be used while overlapping or bending. What do you think about the possibility that solid-state batteries can replace lithium in the future? Please share with us one of your comments. The replacement of lithium batteries will be a major turning point for solid-state batteries to expand beyond the market, not just in electric cars, but it's also widely installed on other energy devices. How will the future of Toyota batteries develop?
The solid-state battery is really exciting. It's a huge breakthrough, potentially in electric vehicles.
If the solid-state battery is successfully launched and installed in electric vehicles, it'll be a breakthrough for Toyota to rise above the world electric vehicle industry. Toyota aims to produce 3.5 million battery electric units a year by 2030, of which half are solid-state batteries. Solid-state batteries will expand applications in pacemakers, RFID, wearables, and electronic vehicles. These are all necessary tools in life, now and in the future, when many environmental and human health problems are gradually changing. The reality of solid-state batteries will support these devices more efficiently and further develop. Not just that, because solid-state batteries can achieve larger capacities and higher outputs than lithium-ion batteries, but more importantly, they have high energy density in their compact size, so they can be used on airplanes and ships. Their compactness will provide additional mounting space for other components without worrying about taking up too much space. Solid-state batteries are resistant to temperature changes across the spectrum from high to low temperatures, which provides absolute safety so as not to lead to fire accidents. Therefore, we can expect the application of solid-state batteries will expand installations and devices used in space. The solid-state battery industry is competing more fiercely than ever when a series of battery companies, car companies like Nissan, Volkswagen, BMW, QuantumScape, also go into research and production. Solid-state batteries bring the most advanced technologies to upgrade vehicle specifications. With the application of solid-state batteries to electric vehicles, it's possible to improve nearly every aspect of the vehicle, from increasing durability, improving safety, reducing weight, and extending range. With those benefits, many car manufacturers and technology companies are investing to acquire solid-state battery technology. Although its cost still has many limitations, manufacturers in the future will certainly reduce the cost significantly by reducing the production process, eliminating expensive materials, and replacing materials replaced by low-cost materials. This time from now until the solid-state battery is fully released is enough for the researchers to complete this battery in all aspects. You'll no longer have to worry about battery limitations because they'll be completely overcome. Toyota and other brands are working hard to launch this battery as soon as possible because they're receiving great expectations from their customer base. Everyone hopes for future electric vehicles that won't have to wait too long to charge or run out of capacity quickly. They look forward to what solid-state batteries will bring with decades of research. So, what do you think of the characteristics of solid-state batteries? Nickel-hydrogen batteries, also known as NiH2 batteries or NHBs, are a kind of rechargeable energy storage system. NASA's conducted extensive research on nickel-hydrogen batteries. Among the important achievements, NASA's developed a bipolar nickel-hydrogen battery design that showcased advantages such as significant reduction in volume, modest reduction in mass, and high pulse power capability. NASA's NiH2 batteries have been utilized successfully in numerous space applications over 3 decades, including the Hubble Space Telescope, where the batteries play a crucial role in providing reliable power. Moreover, NASA studied NiH2 batteries' safety and durability, leading to a better understanding of the operating mechanisms and lifespan prediction models. In the context of the International Space Station, NASA uses NiH2 batteries in certain applications, such as maintaining an optimal operating temperature for some of the ISS's equipment, or providing power to the Hubble Space Telescope's scientific instruments and communication systems during its orbit in the Earth's shadow. NASA's research contributions have advanced NiH2 battery technology and facilitated the battery's use in many spacecraft, including geostationary operational environmental satellites and defense meteorological satellite programs. So how do nickel-hydrogen batteries work? Enervenue, a nickel-hydrogen battery development company, announced that it opened a 1 million square foot gigafactory on a 73-acre site in Shelby, Kentucky, where it'll design, manufacture, and test its nickel-hydrogen energy storage vessels. In these nickel-hydrogen batteries, you have 2 important parts, the positive electrode and the negative electrode. The anode is made of a porous nickel matrix that absorbs and releases hydrogen gas during charging and discharging. The cathode, on the other hand, is made of nickel hydroxide, which interacts with the electrolyte during these processes. When the nickel-hydrogen battery charges, hydrogen gas is produced at the cathode and moves to the anode, where it gets absorbed in the porous nickel structure. During discharging, the hydrogen gas is released from the anode and travels back to the cathode, where it interacts with the nickel hydroxide, converting it back into nickel and hydroxide ions. One fantastic thing about these nickel-hydrogen batteries is their ability to undergo many charge-discharge cycles without significant degradation. This characteristic makes them perfect for long-term applications, like space missions, where reliability and durability are a must. These batteries have been highly favored in the world of space exploration, where they've powered satellites, space shuttles, and various missions. They boast high energy density and excellent performance in the vacuum of space. Although nickel-hydrogen batteries are prevalent in aerospace, they aren't as commonly used in everyday consumer electronics like our smartphones and other gadgets. This is partly because of their cost and because other battery types, like lithium-ion, tend to fit better in consumer devices. Nonetheless, they remain an essential technology for space missions and have certainly played a vital role in our exploration of the cosmos. How much does a nickel-hydrogen battery cost? All right, let's talk about the cost of nickel-hydrogen batteries. Now, the price of these batteries can vary significantly based on their size, capacity, and usage. You see, nickel-hydrogen batteries are a bit less than other types. It costs $83 a kilowatt hour, nickel-cadmium costs $400 per kilowatt hour, and nickel metal hydride is currently priced at $250 per kilowatt hour. The important reason for that is that they're often used in aerospace and space missions, where they need to be super reliable and have a long life. For nickel-hydrogen batteries, like the ones in gadgets or specialty devices, you might pay anywhere from $20 to $100 or so. But hold on, if we're talking about the big boys, the ones used in space missions, well, those can cost thousands, sometimes even tens of thousands of dollars. They're pretty pricey. In light of the recent developments in nickel-hydrogen battery technology, there's promising potential for significant cost reduction and increased accessibility in large-scale grid storage applications. Enervenue, a leading company in this field, aims to tackle the cost issue through two strategic approaches. First, they're leveraging the economy of scale and mass production capabilities offered by their upcoming gigafactory. By assembling these batteries in large quantities, the company anticipates a reduction in production costs, making them more affordable for customers. Enervenue secured 805 megawatt-hours worth of firm orders, indicative of the confidence in the proven and reliable technology of nickel-hydrogen batteries. Secondly, Enervenue is addressing the expressive component challenge, particularly the use of platinum as an anode inside the nickel-hydrogen battery. They've successfully replaced platinum with a cheaper and more efficient bifunctional nickel-cobalt alloy catalyst, making the production process more cost-effective. This breakthrough's not only reduced the overall battery cost, but has also enabled Enervenue to meet the U.S. Department of Energy's target of $100 per kilowatt-hour for grid storage. The successful commercial development of Enervenue's technology demonstrates the practicality and feasibility of these cheaper alternative catalysts, providing hope for further advancements in making nickel-hydrogen batteries more affordable and accessible for large-scale energy storage applications. So what do you think about the price of the nickel-hydrogen batteries? Leave us a comment and let us know. Next in today's episode, we'll find out how efficient a nickel-hydrogen battery is. Nickel-hydrogen batteries have a picture of a device resembling a scuba tank, and that's a member of the metal hydrogen battery family. What sets these batteries apart is their unique chemistry and engineering, enabling them to retain a remarkable 86% of their capacity and achieve 100% Faradaic efficiency even after an astonishing 30,000 cycles, which is roughly equivalent to 30 years of usage. Now, we know what you're wondering. How do these batteries do in extreme temperatures? Well, you'll be happy to know they're remarkably temperature tolerant, functioning seamlessly even in the most frigid or sweltering conditions found in space. And let us assure you, safety is a top priority with these batteries. Rigorous tests have demonstrated their reliability, and they don't suffer from dendrite formation, which can be a common factor that limits the lifespan of other battery types. Though it sounds like these batteries could explode like the scuba tank, that's not the case. In testing, Enervenue deliberately perforated their batteries with nails and even a variety of firearms. They saw no explosion, no fire, and no materials being ejected from the battery, not even the bullets. Also, during these tests, the surface temperature of the cell topped out at a reasonable 44 degrees Celsius or 112 Fahrenheit, and both the pressure and voltage dissipated as soon as the battery was perforated. So no explosion, the hydrogen dipped out safely, and neither the heat nor the electricity could start a fire. That's a pretty solid safety report card. And that's backed up by a test from NASA, showing that even in the event of a hypervelocity impact, NASA's nickel-hydrogen batteries didn't catastrophically rupture or experience an unusual thermal event. And another thing to consider, the low maintenance requirements of nickel-hydrogen batteries. With no need for frequent checkups or interventions, these batteries give us peace of mind and a hassle-free energy storage solution. In terms of capacity, nickel-hydrogen batteries really shine compared to other rechargeable batteries. They offer a pretty impressive specific energy, making them a reliable power source for various applications. Moreover, in satellite uses, they boast an incredibly long cycle life at 40% depth of discharge, proving their durability and dependability in space missions. The good news is that these batteries can handle overcharging, as long as we can manage the heat generated properly. This special quality makes nickel-hydrogen batteries truly reliable and sturdy, able to handle different charging situations with ease. The hydrogen pressure acts as a reliable indicator of this battery's charge level. As the battery discharges, the hydrogen pressure gradually drops, giving us valuable clues about its energy levels. Example: in one communication satellite battery, the pressure at full charge was way up at over 500 pounds per square inch, equal to 3.4 MPa. but it decreased quite a bit to about 15 psi, equivalent to 0.1 MPa at full discharge. If the cell gets overcharged, the oxygen produced at the nickel electrode reacts with the hydrogen inside the cell and forms water. As we look to the future of renewable energy and the critical role of grid-scale storage, nickel-hydrogen batteries do present us a promising option. Their impressive capacity retention and Faradaic efficiency over extensive cycles means they can endure the test of time and provide reliable energy storage for decades. Now, it's important to note that research and technological advancements are ongoing. For those of us who like to stay informed and keep an eye on these developments, could lead us to an energy-efficient and sustainable tomorrow. So how can nickel-hydrogen batteries replace lithium-ion batteries in the electric vehicle market? Lithium-ion batteries currently dominate the market due to their high energy density, faster charging capabilities, and lighter weight. However, its future advancements in nickel-hydrogen battery technology could lead to its adoption in electric vehicles. Because of its longevity and durability, nickel-hydrogen batteries have demonstrated long cycle life and durability in aerospace and satellite applications. If these characteristics can be translated to electric vehicle use, it'd reduce the need for frequent battery replacements and improve the overall lifespan of EVs. Talking safety, nickel-hydrogen batteries have a strong safety track record, making them less prone to issues like thermal runaway or fire hazards compared to some lithium-ion battery chemistries. If significant safety improvements are made to nickel-hydrogen batteries, they could become more attractive for electric vehicle applications. Additionally, it has many advantages for the environment. Lithium-ion batteries rely on the mining and processing of lithium, which can have environmental impacts. Nickel-hydrogen batteries may present a more environmentally friendly alternative, depending on their production and recycling processes. Besides, nickel-hydrogen batteries have an abundance of materials. While lithium resources are relatively limited, nickel is more abundant in the Earth's crust. If nickel-hydrogen batteries can be produced at a lower cost due to the availability of nickel, it may drive increased adoption in the future. Lastly, as battery research and development continue, advances in technologies and new breakthroughs may lead to improved nickel-hydrogen battery technology, such as higher energy density and faster charging capabilities, making them more competitive with lithium-ion batteries. Currently, nickel-hydrogen batteries already offer certain advantages, and there's great potential for even more progress in the future. As scientists work to improve their energy density and reduce weight, these batteries could rapidly become a practical alternative to lithium-ion batteries in the electric vehicle market. You see, evolution's an ongoing journey of continuous developments, with researchers and manufacturers constantly innovating to enhance battery performance. So keep an eye on these exciting advancements, as they could shape the future of electric vehicles profoundly and positively. When do you think this transition will happen? Are you looking forward to using a nickel-hydrogen battery for your electric car? What's the future of nickel-hydrogen batteries? Well, over the last 30 years, nickel-hydrogen battery technology has become widely used in satellite applications. These batteries have shown great reliability and have been a top choice for powering satellites up in space. Now, enter venues working hard to tackle the high cost of these batteries by using mass production and standardization in their gigafactory. By making lots of them at once, they hope to bring down the price and make nickel-hydrogen batteries more affordable for various uses, including large-scale energy storage. Now here's something interesting. Because of their higher specific energy, these nickel-hydrogen batteries have been used in all communication satellites since the 90s. That's a pretty impressive track record, right? So this means that these battery advancements could lead to better and more affordable energy storage solutions for everyone. As we get older, it's essential to stay informed about these technologies that can impact our energy needs in the environment. With nickel-hydrogen batteries already proven up in space, it's promising to see how they might expand in other areas too. Keeping up to date with these exciting developments can help us make wise choices for a brighter and greener future for ourselves and our grandchildren. Recently, there's been an exciting development in the world of cold fusion power. The very first test of a low-energy nuclear reaction generator is all set to take place in Greece in October. It's powered by Andrea Rossi's energy catalyzer cold fusion device, which uses a nickel-hydrogen reaction to create heat and produce steam for generating electricity. Can you believe it? This device is expected to generate a whopping 1 megawatt of heating power, enough to heat about 1,000 homes for an entire hour. So what do you think about the future of nickel-hydrogen batteries? Would you use this battery system in your own home? Leave us a comment and share your thoughts. So, how successful have nickel-hydrogen batteries been in the past? Back in 1970, during the height of the space race tensions, ComSat Laboratories came up with something truly remarkable named nickel-hydrogen batteries. These batteries were originally created for satellites and probes, combining the positive nickel electrodes from nickel batteries with the negative electrodes from hydrogen fuel cells. And what's fascinating is that they use highly pressurized hydrogen gas to work their magic. These NHBs have been nothing short of a success story, proving their mettle in various space missions over the years. Just think about it. They've been powering incredible space missions like the ISS, the Hubble telescope, and even the Mars rover. Their reliability and impressive performance in these space endeavors made them the go-to power source for exploring and learning about the vast universe above us. Now, the achievements of nickel-hydrogen batteries are nothing short of astonishing. These advanced batteries have been part of some of the most incredible space missions in history, allowing us to explore and understand the wonders of the cosmos. They're the result of smart folks combining the best of two technologies: nickel batteries and hydrogen fuel cells to create a powerhouse of energy that can handle the tough conditions of space. From keeping the International Space Station up and running to supporting the groundbreaking discoveries of the Hubble telescope and aiding in the exploration of the red planet Mars, these nickel-hydrogen batteries have truly shown their worth. And that's it for today's episode. What do you think about these batteries?
Are saltwater batteries. A saltwater battery is a type of battery that uses a mixture of water and salt as its electrolyte. Saltwater batteries are non-flammable, safe, have long lifespans, and are not prone to pollution. They are considered to be an eco-friendly energy storage solution, possibly more so than lithium-ion. The main difference between saltwater batteries and other batteries in energy storage is their chemistry. In saltwater batteries, a liquid solution of salt water is used to capture, store, and eventually discharge energy, whereas a traditional lithium-ion battery uses the element lithium as its primary ingredients for conducting electricity. So how does it actually work? There are three principles that this battery follows. They include taking the form of two tanks, a catholyte and an anolyte. These tanks surround a chamber that splits down the middle, and the liquid electrolytes flow from the tanks into either side through the process of reduction. Next is redoxing, where the electrons from the catholyte transfer to the anolyte as the battery is being charged. And last, its tanks contain chlorine gas dissolved into a proprietary electrolyte, while the other tank is full of nothing but sodium chloride and water. What's more, saltwater batteries have the same structure as sodium batteries because they are all made of salt water and moving sodium ions that generate electricity for the battery. So then how are saltwater batteries more affordable than other batteries? US-based company SalGenX has proposed its saltwater flow battery with a component of salt, water, and vanadium electrolyte. SalGenX claims that its saltwater flow battery is less than $100 per kilowatt hour. The main reason is that besides taking advantage of the ubiquity of salt water, means saving a lot of money, the cost of its batteries, electrolytes, is less than $5 per kilowatt hour. Another American company, ESS, is also experimenting with saltwater flow batteries. Like the SalGenX battery, it operates with a saltwater electrolyte, but it's using iron salts in water instead. Where vanadium electrolytes in SalGenX's battery can represent as much as 80% of a flow battery's cost, iron electrolytes of the ESS battery makes up for only about 4%. Saltwater batteries are a relatively new type of battery that has been gaining popularity in recent years. They are often touted as a cheaper and more sustainable alternative to traditional batteries. However, when it comes to comparing their price with other batteries, the picture is a bit more complicated. First, it is important to note that there are many different types of batteries on the market, and their prices can vary widely depending on their intended use, size, and technology. For example, the SalGenX company claims that there are $257 per kilowatt hour for system infrastructure and a total cost of $500,000 or $166 per kilowatt hour for the 3,000 kilowatt hour battery. On the other hand, the other reason for this is that they use more common and cheaper materials such as salt water. Additionally, they are easier to manufacture and do not require the same complex chemistry as other types of batteries. The manufacturer said the new battery has an energy density of 125.7 watt-hours per liter. It requires 2 large tanks filled with fluid electrolytes, one of which is salt water and the other is a proprietary electrolyte. The solution can be scaled by adding more electrodes and additional electrolyte tanks. SalGenX had a plan to offer the solution in 250 kilowatts, 3 megawatt-hours, 6 megawatt-hours, 12 megawatt-hours, and 18 megawatt-hour configurations. The flow battery is membrane-free, unlike most redox flow batteries. The absence of the membrane saves huge upfront purchase costs, maintenance, and consumable expenses, SalGenX says on its website. And what of the life cycles of saltwater batteries? Saltwater batteries have long life cycles, up to 25 years, compared with lithium EV batteries, which have a 15 to 20-year shelf life. Meanwhile, other batteries like lead-acid batteries can have a design life in the ballpark of around 5 years, depending on the manufacturing process of the battery. From this, we can safely say that saltwater batteries have 5 times the longevity of lead-acid batteries in the competitive battery industry. Additionally, the saltwater batteries have a simple design since they are extremely durable and long-lasting. A regular saltwater battery lasts for nearly 5,000 cycles, 5 times higher than lithium-ion batteries, which only last around 1,000 cycles. What's even more fun is that the lead-acid battery has a life cycle lasting 500 cycles, demonstrating that its lifespan is 10 times less than that of saltwater batteries. But since the saltwater battery is not prone to explosions, you can use it beyond the indicated cycles safely. That means you will likely not have to replace a saltwater battery as often as you would with most lithium-ion batteries, which can save you money in the long run. Based on its simple design, saltwater batteries offer direct control over their energy and storage capacities as long as it has enough electrolytes. It can theoretically increase the storage as much as you want by increasing the size of the tanks. And if the number of the electrode cell stacks are increased, that means more power. ESS announced that the maximum storage duration mark of their iron flow batteries is 12 hours, which remains greater than lithium-ion batteries at 30 minutes to 3 hours. So what are the financial benefits of saltwater batteries? First of all, saltwater batteries have a huge advantage from material cost. Salt and water are widely available and are at a low cost. For instance, the price of material salt is around $80 per ton, which is less than 462 times that of the $37,000 per ton price of raw materials for manufacturing lithium batteries. On the other hand, there is no regular maintenance. You will also save over $3,000 every 15 years. According to an invoice from Tesla shared by Current Automotive, a complete 75 kilowatt-hour battery replacement for a Model 3 costs $16,550.67. That's $2,299.27 in labor and $14,251.40 in parts, with the actual battery costing $13,500. However, battery prices may vary depending on your vehicle model. As Rich Rebuilds shared, remanufactured packs cost between $9,000 to $17,000 depending on the complexity of the work, while new batteries can cost up to $22,500. Overall, the economic benefits of saltwater batteries are numerous. This greatly strengthens the position of brine batteries in the industry. But most importantly, how safe are saltwater batteries? There are several advantages to saltwater batteries when it comes to safety. Firstly, it's non-toxic and non-hazardous. Unlike traditional batteries that contain toxic chemicals like lead and sulfuric acid, saltwater batteries are non-toxic and non-hazardous. This means they pose no threat to the environment and are safe to handle and dispose of. Secondly, it's fire resistant, so no fire risk, not flammable or explosive, whatsoever. Other companies like ESS used salt and water and an iron electrolyte to create their own saltwater battery. Mr. Eric Dresselhuys is the CEO of ESS Incorporated. He tweeted that there's no toxicity, the technology we build doesn't start fires or doesn't blow up in a fire. And this company announced their test of this saltwater battery on Twitter. Our long-duration batteries do just fine in extreme weather, as this system running in the 115-degree heat of Nevada proves. No need for HVAC cooling and no risk of fire. They also have a very low risk of leakage. While traditional batteries are prone to leaking, which can be dangerous if the chemicals come in contact with skin or eyes, saltwater batteries have a much lower risk of leaking since they do not contain any corrosive chemicals. And if the container gets ruptured somehow, then it's safe to touch because it's just salt and water. Also, I can't stress this enough, but saltwater batteries are environmentally friendly. One of the advantages of a saltwater battery is that it is made up of salt water, which is environmentally benign materials, unlike toxic metals and other materials that most lead-acid or lithium-ion batteries use. Moreover, unlike other manufactured battery processes that use harsh chemicals such as cyanide or mercury, saltwater battery production relies on salt and water, which are safe and easy to obtain. Moreover, the process can be done entirely by hand without the need for electricity or other energy sources, making it a very low impact and sustainable technique. And lastly, because saltwater batteries are the safest materials, discarded battery parts may be recycled more easily. At the same time, these batteries are easy to dispose of once they have served their purposes. In contrast with lithium-ion batteries, it takes a professional and specialized business to handle the dismantling of a lithium battery while it is recycled, due to its great potential for explosion. Other batteries cannot be recycled outside either, since they are made with harmful elements like lead, acid, or heavy metals like manganese, cobalt, and nickel from lithium-ion batteries. Next, how are saltwater batteries more efficient than other batteries? With a life cycle of roughly 5,000 cycles at 100% depth of discharge, saltwater batteries have a significantly higher life cycle compared to lithium-ion batteries, which have a conventional life cycle of 100% up to 1,000 cycles. Additionally, lead-acid batteries will gradually lose capacity after only 500 cycles, which is 10 times less compared to saltwater batteries. The key takeaway is the high energy density. Saltwater batteries have an energy density of 100 watt-hours per kilogram, while lead-acid has a much lower energy density of 25 to 35 watt-hours per kilogram, which is around 4 times less compared to saltwater batteries. In general, the saltwater battery is made of low-cost materials, yet the quality of the final product is extremely good. Manufacturers can produce low-cost, high-quality batteries with ease. This is significant evidence that saltwater batteries will be feasible to replace in the battery industry in the future. Based on its high energy density, these saltwater batteries can get charged and discharged just like any 48-volt battery bank as an example. You can use solar panels with a charge controller, an inverter or charger connected to the grid, or a generator, a 48-volt wind or micro hydro turbine, and any way you charge as a 48-volt battery. Saltwater batteries allow full discharge without harming the battery. Also, fully discharging the battery does not affect the life cycle of the storage system. Additionally, the stored energy inside the battery can go for days or even weeks without charge. For this reason, battery maintenance systems to control the charge are unnecessary. But at what temperature range can saltwater batteries safely operate? The operating temperature is fairly wide, as much as 23 to 104 degrees Fahrenheit, or around -5 to 40 degrees Celsius. Saltwater batteries can still freeze at 14 degrees Fahrenheit or around -10 degrees Celsius, but you can thaw them and they will still work. A simple enclosure should be enough to prevent battery temperature from going below 23 degrees Fahrenheit or -5 degrees Celsius. A number of factors can influence the operating temperature, including the following. Number 1, overall ambient temperature. Number 2, the enclosure of the battery and whether it is vented or sealed. Number 3, whether the load itself creates heat. And 4, your devices are nearby other heated equipment or other sources of heat. Exceeding standard operating temperatures will yield many harmful consequences. such as operating in excessively high temperatures for a power supply can reduce its lifetime. Occasional operation at temperatures modestly higher than the specified limits may not lead to any appreciable difference in lifetime, but the longer a power supply is operated this way, the shorter the lifetime will be in general. And in the case of extremely high temperature excursions for even brief periods, specific malfunctions or outright failures can occur quickly, often due to individual component malfunctions or breakdowns incurred by the high temperatures. Inversely, in low temperatures, a reduced lifetime of product failure from low operating temperature is rare, except in the most extreme cold conditions. In extreme cold, and especially when stored that way for a long time, the seals on the electrolytic capacitors in the power supply can fail. Such a failure will result in the non-operation or out-of-spec performance of the power supply. Now it's time for some trivia. Who was the first to commercialize saltwater batteries? U.S. startup Saltwater unveiled a saltwater flow battery for large-scale storage, which is a redox flow battery with two separate tanks of electrolytes, one of which is saltwater. Unlike other flow batteries, the new device is membrane-free, promising big gains at the levelized cost of storage. The saltwater tank can be used simultaneously for thermal storage, in combination with a heat pump using carbon dioxide as a refrigerant. Saltwater's strategy is developing the technology and selling licenses to third-party manufacturers to commercialize the solutions. Additionally, in February, ESS used salt, water, and iron to manufacture their battery. They announced its collaboration with the Turlock Irrigation District, which is a California-based utility. ESS will also be installing saltwater flow battery facilities in Sacramento, California as part of a collaboration with the Sacramento Municipal Utility District starting this year. Currently, saltwater batteries can do a variety of useful tasks that other batteries cannot. In battery production, a liquid solution of salt water is used to capture, store, and eventually discharge energy. While a traditional lithium-ion battery uses the element lithium as its primary ingredient for conducting electricity, a saltwater battery uses, you guessed it, sodium, the same element found in table salt. In other industries, it is used to produce fresh water. The Saltwater's redox process can also be adapted to produce graphene. Additionally, the saltwater battery chemistry is optimal for cycling applications or EV batteries and stationary long-duration telecom systems. It is also used for applications in renewable energy, telecommunication towers, oil well pumps, agriculture irrigation pumps, and greenhouse irrigation, or lighting. The batteries are suitable for standalone storage or with solar or wind power. When can saltwater batteries become a leader in the battery industry? Let us know your thoughts in the comment section down below. Thank you so much for watching, and if you enjoyed the video, please leave us a like, subscribe if you haven't already, and be sure to ring the bell so you'll stay up to date on new Tesla Car World content. Once again, we thank you so much for watching, and we hope to see you again next time. Until then, take care and be safe.